for the Big Data Pilot Demo Day webinar from the Track and Know project on the insurance sector, using mobility data to understand and mitigate risky driving behaviour. I'm Jenny Rainbird, a project manager from Inlicom Systems, who are the coordinators of the Track and Know project. Before we start, I'd like to provide some general information. The webinar is in listen-only mode, and we invite you to pose questions using the Q&A chat box, and we'll answer the questions at the very end of the webinar. The webinar will be recorded, and both the slides and the webinar will be available via the Track and Know website in a few days. Here's an overview of our agenda for today. To help us understand our audience, we'd like to kick off with a short audience poll. I will then give an overview of the Big Data webinar series and an introduction to today's speakers. Marios Logothesis from Intrasoft will give an introduction to the Track and Know approach and architecture. Then Leonardo Lonchi from Systematica will present the requirements of the insurance pilot and deliver a demonstration. Dr. Tony Strokova from Cambridge Medical will provide an introduction to the next webinar in the series, which is the application of big data to the healthcare sector, and then we will have a Q&A session before we close. Our poll today is 5 short questions to help us understand our audience and their interest areas. The questions are multiple choice and include the following. Which stakeholder group do you belong to? Are you working in the insurance service industry? Are you working with big data? Are you interested in big data technologies to optimize your customer experience? And what is the main barrier or risk preventing you from implementing big data analytical solutions in your organization? I will now open the poll. Please take 1 or 2 minutes to respond to the questions. Thank you for starting to respond to the poll. I can see that a number of our audience are from research and academia, but we have 8% from the finance and insurance sector and 13% from big data technology providers. 5% of our audience today are working in the insurance service industry, and 80% are working with big data. 70% are interested in big data technologies to optimize the customer experience. And over half of you have indicated that the main barrier to implementing big data is lack of expertise. Thank you very much for participating in our poll. As an overview to the Big Data Demo Days webinars, these webinars are driven by the Big Data Stack and IBIDAS project. A number of the Big Data Value PPP research projects came together to form an initiative to deliver a series of webinars under a common theme of big data research demonstrations. All projects are aimed at addressing the growing need for big data technologies to unlock the potential in various application domains. IBIDAS, Big Data Stack, and Track and Know and Policy Cloud are developing innovative technologies to address the emerging needs of data operations and applications, and are using pilots to demonstrate the sustainability and applicability of these solutions in a wide variety of sectors. As IBIDAS, Big Data Stack, and Track and Know reach their final year, they are ready to demonstrate the developed and implemented technologies to interested end users from industry, as well as technology providers for further adoption. In the newly initiated Policy Cloud project, they will be highlighting the adoption of technologies developed by Big Data Stack, showcasing its application for the policy-making sector. There are 4 BVA PPP projects joining forces to showcase application of innovative technologies, fostering further adoption and contributing to Europe's digital future. Big Data Stack are developing a holistic stack for big data applications and operations. IBIDAS are researching industrial-driven big data as a self-service solution. Track and Know are focusing on big data for mobility tracking, knowledge extraction in urban areas. And Policy Cloud is looking at developing cloud for data-driven policy management. This webinar from the Track and Know project on the insurance sector, using mobility data to understand and mitigate risky driving behaviour, is the 8th in the series of webinars, which cover areas including the financial sector, shipping, policy communication, and manufacturing. All of the webinars are or will shortly be available via the BDVA PPP and each project's website. Today's speakers are Marios Logothesis from Intrasoft. Marios is a senior researcher and innovation manager whose interests include the identification of application areas and commercialization models where new emerging technologies such as big data analytics, Internet of Things and blockchain provide a positive impact. Marios is the Track and Know platform integration lead and will give an introduction to the Track and Know approach and architecture. Leonardo Longhi from Systematica graduated in Biomedical, Electronic and Communication Engineering at the Department of Applied Electronics at the Roma Tre University. His thesis was concerning pattern recognition methods for machine learning applications to recognize drowsiness and lack of focus by analyzing facial expressions. He has also been collaborating in developing business for Italian startups until 2016. In biomedical applications and in the signal processing business areas, after which he shifted to applied informatics in insurance and telematics products. He is currently working as a consultant for one of the most important telematics companies in Europe and is the Track and Know Insurance Management Pilot Lead. It is now my pleasure to hand over to Marios from Intrasoft for an introduction to the Track and Know approach and architecture. Marios, the floor is yours.
Many thanks, Jenny. Hello to everyone. Let me share my screen. I hope that you all see my screen now. So what I'm going to very quickly present you is the Track and Know platform and let's say some architectural aspects of that platform. So before going to the presentation of the platform, I would like to highlight some challenges and business needs that we have identified during the initial, let's say, the first year of Track and Know project. So what we have identified is, first of all, that we have a shift in the software development paradigm, and now we have more, let's say, a lot of data to handle. So the main work was that we have changes from complex coding that we already had at the past to data handling code. So in order to handle this big data, as we say, we identified and we have created the following solution, which is a data streaming and analytics platform that it was capable to offer real-time monitoring and event processing. It was a distributed messaging system platform with some of characteristics was that it was highly scalable and with high fault tolerance. So in one, let's say, sentence, we were able to decouple the complexity of the different data sources and databases from any, let's say, data processing or analytics tools. In more detailed platform, you can see at the middle of the figure where actually it is the platform. So at the left side, we have different data sources. For example, it could be data streams coming from IoT devices, or we can have some batch data or any database that exists our data. So in order to ingest those large amount of data, we have created some connectors depending the type of the data. And for specific data model where we have used the schema registry coming from Kafka, which is the Avro, we were able to create this streaming core platform. As you can see, the technology that we have used here is the Kafka Connect and some custom connectors. And all of them are open source solutions. So at the right side of the architecture, you can see where actually there are the analytic part or the visualization part that Leonardo then is going to describe. So just to summarize what we have done with the platform, as I told you, it's a distributed streaming platform for handling real-time data. And as I told you, it is based on open source Apache Kafka. So it can very quickly ingest large amount of data and creating processing pipelines. Some of the characteristics of the platform, again, it's real-time and real-time monitoring and event processing solution. And it can interoperate with all modern data storage technologies. It is a distributed messaging system. As a matter of fact, we have deployed in 16 virtual machines. Again, some characteristics, it is high scalable and high fault tolerance. And we have also designed by having in our mind the security in the encryption, authentication, and authorization of the users. Just to highlight that we were able also to see some other benefits of using that platform, but we didn't investigate it during the track and all, but we thought that it will be also the use of Kafka help us in the continuous delivery of machine learning. And when I say continuous delivery of machine learning, is actually that with that technologies we were able to first of all train any ML model and be able as a next step to inference that model in both at the edge or in the cloud. And in parallel, we were able also to monitor the model, to alert, and of course, continuous improvement of that model. As I told you, it was deployed in 16 virtual machines in order to perform any of the pilot that Leonardo will show next. As a final slide, I would like also to highlight some other use cases that we have identified that probably such a platform can help in situations like, for example, monitoring, real-time monitoring, or connecting any type of metrics, alerts, KPIs. And as you can see, there are some Netflix or Airbnb is at the moment using for such scope that type of platform. Of course, one of the, let's say, the first use cases that Kafka has been introduced to the industry was first of all introduced by LinkedIn, and the purpose was for message use in content fields. Another more related to our scope in Track&O was the real-time processing analytics that we have performed. And last but not least, we can use the same platform in order to perform to have a distributed data center or a distributed log system. So thank you very much for your time, and I pass the floor now to Jenny and Leonardo. Thank you.
Thank you, Marios, for that overview of the Track&O approach and architecture. I would now like to hand over to Leonardo Longhi from Systematica to present the requirements of the insurance sector pilot and then to provide a demonstration. Leonardo, the floor is yours. Thank you.
Thank you, Jenny. Thank you, Marios. I'm sharing a screen right now. Okay. Okay. So, welcome back. Thank you for joining this webinar. I'm Leonardo Longhi. I work for a Systematica SPA that is a partner of the Track&O project that is on 2020. I also work for insurance companies and for telematic service provider, and as well as car manufacturing, electric vehicle industry. And I will briefly show our company and field sector in which we work, and especially the one that you are interested in mobility firmware, and how the ETP department and cloud services to serve its clients and its customers. And it develops customer solution for insurance sector, as well as electric vehicle manufacturer and fleet management services. So in this webinar, we are going to show you some concept and two products, basically, for machine learning to estimate and decrease insurance risk on the road. And this tool is also used for carpooling, matching, and switch, and as a leverage to convince customers to switch to an electric vehicle mobility. Let's say a bit more in focus. The dataset that Systematica provides to Track&O consortium are basically in London metropolitan area, in Italy, in Rome metropolitan area, and in Tuscany region, still in Italy. We focus on these three geographic areas because there are very, let's say, important research topic, because there are two metropolitan cities like Rome and London, and one countryside and with small towns and big cities, middle big cities like Tuscany. And the dataset is composed by 1 terabyte of data, more than 500,000 of private cars with mixed sampling rates. It's not fixed sample rate. And we provide information about speed, heating, acceleration, location type of the road, and of course, full labeling of driving behavior events. Let's say acceleration and the measurement, maximum and average acceleration over the different type of driving behavior events, brakings, cornerings, quick lateral movements, like say to avoid obstacles during the drive, during the trip, and of course crashes, because we are working with insurance companies that provide also crash reports. We collect in this dataset are about 2 billion of WJS84 GPS position, with a quality flag, a quality labeling on the data. So basically, there are full coverage of GSM with 3 antennas. So a good quality of GPS position, the best that is provided right now. This is the general, let's say, work modality for our company. We develop also boxes for electric vehicles, and we install also boxes for insurance sector. These boxes are communicating to a central server that is going to decode and to validate the quality of the data, the raw data, and then to store it or to push it by Kafka or by other system queue systems for online analysis and offline analysis to our customers. Our clients are both in this sector, but also systematically is developing solution both for the dispatching area and to offline analysis and online analysis too. So we propose a pilot in the Track and Note consortium that is architected like this. We simulate the streaming data or the batch, let's say historical data, in a MongoDB server that provides raw data to a Kafka producer. Then the consumer consumes the raw data input to push it into the online pipeline. The online pipeline performs a data cleansing on the GPS data and then an identification interpolation matching for the trajectory, let's say, synthesizes. And also a weather and point enrichment for several applications, and for that we will see later on this webinar. The output of the data are for now just stored in the same Mongo staging area, just for test, and again pushed in the offline analysis. That is what I will show you briefly in next slides, that performs the risk prediction and the risk mitigation, and with also other particular operations that clients ask to us every day. At the end, the output is shared by Kafka with our customer and visualized, of course, by dashboards, and again stored as a statistical value to be retrieved in the second moment. We choose Mongo because, of course, it's an open source technology, and it's a NoSQL. And for big data, NoSQL, of course, is the must-have technology to implement. But Mongo is also very, very good for our application because it supports geospatial indexing and it supports GeoJSON format. So let's move. Let's take a look of the market in the insurance and telematic market sites. So here is a very simple graph of the world market in the world insurance market. As you can see, you can say that the Americas and the Europe and Middle East has a lot of revenues in these areas, that is insurance. However, the car market is changing now, because Asia and Pacific is developing a lot of vehicles, electric vehicles, with a low prices. So basically, as soon as this technology, and it is still happening right now nowadays, as soon as the laws and the insurance regulation follows this market, we will assist in the same increasing of this market as well as Europe and Americas. And as you can see, the leverage for this market are several, and basically proactive government initiatives will rise from nowadays to 2025, as well as for increasing demand for full efficient and high performing and low emission cars and vehicles. And then we will have a more stringent government rules and regulation towards vehicle emission, of course, and we will assist to a slight decrease of the manufacturing cost. So, how is the market split? Let's say that for industrial reason, from the name of the companies, of course, for privacy reasons, but we found that there are $130 billion by 2025 of revenues expected, and more, that 150,000 employees by 2025. The company 6, let's call it like that, get the control of the 98% of the market. However, the control of this market is related to industrial and not private vehicles. In the remaining is shared by almost six companies that are under our lens right now, because their future is increasing. So we performed 2 rankings of this, the 25 major companies, the players in this market, and we sorted it for the ratio between revenues and number of employees, and the ratio between and the percentage of demand coveraging. We can see that the previous 6 companies that are started here, they have a very high percentage coveraging, and of course a very high futures. I have a ratio between revenues and employees. So how our pilot is, what kind of services can we offer? Of course, we can, the pilot one of the Track&Know projects focus on insurance target market and car rental and auto dealers. And the asset type is mainly passengers and generic assets. As you can see, is a vertical market here and here, because it shows a low market saturation. And the devices that are provided are, let's say, a very wide range of BD based, of OPU based, and smartphone based. And we can provide also services for vehicle asset and registry configuration, driving behavior and coaching, as we can see in some slides, and driver management and connect insurance integration. Okay, let's take a look at the requirements that we collect from our stakeholders and from the market analysis about the insurance business case. So we would like to perform an analysis and estimation of the risk associated by each driver by observing it for a few months, a few weeks, and trying to predict if the risk of having a crash with the feature selected is probable or not. And by that risk, we will find out the principal suggest strategies to the insurance companies in order to coach the driver, to let them
Hi, Leonardo, it's Jen. I think we've lost your audio there. Hi, Leonardo, it's Jenny here. Unfortunately, we can't hear you at the moment. Hi, Leonardo, we've stopped sharing your screen. Can you speak again to see if we can hear you?
Yes.
Okay, you're back with us now. Thank you.
Yeah.
That's great.
I'm so sorry, I don't know why. Okay, I will share my screen right now. Can you tell me if you see my screen?
Yes, we can see the screen.
Wonderful. So back to the presentation. Okay. So moving on. Solution of the insurance business case basically is calculating risk. Risk is basically a hidden cost of the society, and it's calculated by multiplying the probability of having a crash accident times the damage of that accident. Of course, this is quite impossible to define because damage is a random Gaussian variable, and of course you can have a very hard crash and be still safe, and then you can have also very slight crash and that wounds you. So basically, damage is out of our analysis right now. Also because actuarial science has demonstrated that the overall damage and the overall risk, let's say, is actually proportional to the probability. And the insurance sector is more focused on the probability to having a crash more than the damage. So we performed the historical analysis, a sliding window over 1 year of tracks of more than 500,000 of users in London, in Rome, and Tuscany, to predict the crash probability in the short future. Let's say we divide the jet set in 3 months of tests, and then 1 month of 3 months of training and 1 month of tests. So we find our basic software tool that is in individual mobility networks. Individual mobility network has trajectories that are clustered in nodes and edges as a graph. And we count, of course, feature to define that. We count events and counting of the trips that we have, the length, the mean average, the duration, the time of the day in which the trip happened, the speed, and so over. We have a lot of featured. These are just 5 of them. And of course, we have also event-based features: acceleration, brakes, cornering, start, stop, crashing, previously happened crashing, of course. And we will also exploit the weather enrichment also to gather more feature about the environment. The training and the test has been performed like that. As already said, Rome, Tuscany, and London has been spanned from a sliding window that trains the model over 3 months and tests over the next month. So basically, by observing one driver from 3 months, we are able to predict his probability to have a car crash accident in the next month. How individual mobility network works? But basically, they are a clustering of trajectories, and trajectory has been divided in hot points, that is start and stop, start and arrival points, and trajectory vectors. The start and arrival points are summarized and clusterized by functions, so we can distinguish function of the stops. Is not by relating the stops and the starts to the map, just to the pause and the time that we spend in one place and in another one. So these are clustered and summarized in nodes, and trajectories are summarized in frequencies, and the graph is referred to the map in this case, but for a privacy reason, we don't refer to any maps. So we have just graphs like that, this one that you can see here, with no reference. These objects are, with this object we extract the most related feature and the most predictive with the crash accidents. And we observed that in Tuscany, and the overall, the rock curve is very encouraging, and we find out, or we can predict the neighbors with 80% of precision and 20% of recall. So this is very encouraging. And here we can say the measure feature and the principal components that we extract in this analysis. And this is very important. This is the method that will allow us to say if the risk can be mitigated. The Shapley additive explanation is some sort of, let's say, labeling that gives a significant label, a significant function to the feature of the model, to give an explanation of the feature, and then with this explanation try to infer to the model in order to shorten, to lower the risk of each driver. This is the graph example in Tuscany. And of course, individual mobility network has also used in Pilot 1 for two other business cases. The one that involves carpooling sector, and the one for electric vehicle business cases that we are going to look at in some slides. These are the requirements of the electric vehicle compliance and the carpooling compliance that are very, very similar. And we are using actually this tool, this software tool, as a power strategy to shorten also the CO2 emission in certain areas, especially London and Rome metropolitan city areas. So from our market analysis, we would like to set find a set of parameters that describe how probably and efficiently the current road might be substituted by an electric car routes, given also the matching between the poses and the charging points network of the city. This is going to be tested and developed by the end of the Tracking project, and we are working on that with very, very encouraging results. And of course, we can estimate for each driver a cost function in terms of money and time, of course, a matching time. If they want to shift from the internal combustion engine cars to an electric car or an electric vehicle mobility. A special goal will be the driving safety in terms of money, and the still matching time schedule compliance between having an internal combustion engine car and having an electric vehicle. This is very important, actually, more for cities like Rome and London. For the carpooling compliance, we still use the individual mobility network to try to substitute and to prune, let's say, the overall mobility trips in order to see which mobility network matches with another. So the two drivers can share a portion of the whole trip if they want. So basically, we would like to prune the overall trips in a city. Okay, let's talk about which is the concept of this scenario and how these three components, these three software products work together to reach a better saving for environment saving and a better income for the world society. So the Go Green widgets for the carpooling and the Go Green widget for the electric vehicle together, they increase electric vehicle services and decrease the cost of the carpooling and increase of the market of the carpooling and the market of the electric vehicle segment. This is, of course, the output of this action is, of course, a traffic decreasing due to the carpooling pruning, let's say, and of course a CO2 emission decrease due to both the electric vehicle shift from internal combustion engine in paradigm to electric vehicle paradigm, and of course also for carpooling. Traffic decreasing means also car crash, collision decreasing, and also we have another product here that can work in this sense to mitigate the risk of the insurance sector, the driving safeguard and coaching. So basically, moving back to the original requirement in the insurance, how can we measure that a car crash is decreasing? Of course, we have a set of historical data. So basically, we can measure how we are good to predict the next crash, but in certain way, we don't measure how we are able to decrease the risk until we find online, let's say, data set in which we can suggest to the drivers some suggestions, some coaching tips, and we will measure from a control group if there is improving by the model. So basically what we gather from the whole pilot, we are estimating the decreasing of the CO2 emission by a historical perspective, that is calculated by the percentage of saved kilometers times the unit cost per car type. We also have the car type related to that trips. We multiplied it for a gamma correction, because the gamma is the parameters that is going to be defined by the market sector and the leverage of how much people, how much drivers would join the electric vehicle, and how much carpooling trip sharing will be joined. So basically, if we equalize this gamma to 1, we have the potential savings in terms of CO2 emissions, and of course in terms of money for electric vehicle and carpooling sharing. For the driving safeguard coaching, we can report the crash accident decreasing just for an inference, let's say, heuristics on the actual model. And we are looking for insurance companies that would like to prove that with their data, with their online data. And so it is, let's say, all from my side. We will have a look on the dashboard. What do you see, Jenny? What do you think?
Yeah, please go ahead and show your videos. We can see your screen now.
Yes, let's say some individual mobility networks of Tuscany. This is the user that are selecting the one of the 10th major risky driver. This is his mobility networks. As you can see, the dots are bigger, basing on how much time is spent in that location. And we can also color the trajectory as green and red basing on the frequency and the risk. We are developing also this widget in order to show which edges is related to which feature. And here it calculates the overall crash probability risk that is around 60% in the next month, looking back to the previously past 3 months. This is the period over here. This is another vehicle, anonymized. This is the period, the month. And this is the calculation of the individual mobility network. Of course, the network is changing by changing the sliding window in time. So it's not a fixed object, it's just related exactly to the observational period. The more you can drive, the more the network is complicated and the more the risk is exposed. Okay. Okay, let's say it's something related to London. Okay, same process. This is the vehicle. The period is set. And this is the calculation of individual mobility network. So the overall mobility network of this driver has been calculated and for privacy reasons are stored in systematical premises. And if you may interested in that data set, please contact us through the consortium. Let us know, and we will be happy to help if it is possible and to promote further research on the field.
Thank you.
Okay, I think that's all on my side. I'm open to receive any question if there
Thank you.
There is. Okay.
Thank you, Leonardo. I'd like to introduce Dr. Tony Strakova from Cambridge Medical to give us an introduction to the next webinar in the series, which is the application of big data to the healthcare sector. And whilst we're watching this presentation, please continue to post your questions in the Q&A chat. Over to you, Tony.
Thank you very much, Jenny. Let me just share my PowerPoint. Hi, everyone. We are here to invite you to our next webinar, which is this coming Thursday, same time. And with this webinar, we will show you another aspect, the versatility of the Track and Know platform for big data management, which will be used in the healthcare sector. So it's the healthcare pilot number 2. Our speakers will be Kieran Lee, who is a research practitioner with the R&D team at Royal Papworth Hospital. Kieran is involved in a range of projects focusing on improving service accessibility and efficiency, predominantly in the area of sleep services, which is obstructive sleep apnea services, under the leadership of Dr. Ian Smith, the director of the sleep services and the R&D director. Then we also have Livia Bruweiler, who is an MSc student in Geographic Information Science at the University of Zurich. Livia is currently working on his master thesis on the topic of car accident risk prediction using GPS trajectories, and Livia will be in charge of our simulation. And this is me. I'm Tony Stakova. I'm a medical doctor working at Cambridge Medical Academy with predominantly clinical innovation projects in the UK and obviously across the European Union. So we will be very happy to have you there. And what are we going to talk about? So the healthcare service, which we are going to show you, has a geographical distribution with a number of clinics across a large geographical area of Cambridgeshire. And we want to show you how with current tools, it is actually impossible to oversee the service, patient attendance, and various aspects of service efficiency. So using the big data tools provided by the Track and Noise system, we will show you how we are capturing the service operations in a totally new way compared to the current operations. We do comparisons between service availability versus real demand, again deploying different tools of the Track and Noise system, and we ran simulations to find out the best percent of these simulations. We can compare the KPIs and provide business intelligence to the operations managers to make decisions on the service deployment, and ultimately this will lead to the works who will be managing the patient. So we're really looking forward to hear in a couple of days' time. Please don't forget us. Join us then. Thank you.
Thank you, Tony, and thank you to all our speakers today. I would now like to open the floor to the questions. And I see that we have some questions in our chat. I'm just going to have to, stop sharing my screen because otherwise I can't see the questions in the chat. Sorry about that. Okay, so I'll come over the questions, put them to you, Leonardo. So let's start with the questions. We only have time for a few, I'm afraid. So the first question then, why does the car prediction in cities show less efficient performance with respect to countryside regional crashes? That's the first question. And we can see your screen, Leonardo.
Sorry, I was muted. Yes, just use this slide as a reference to answer this question. So I think that okay, this is the reference slide. Yes, the observer has captured that on Rome and London is same. The rock curve is still a bit with less performances with respect to Tuscany and to the overall mean. And this is why, because the metropolitan areas are fully as a full environment with feature that we don't even consider in right now. For example, major pedestrian rate, major pedestrian people is moving around, and the traffic other features that should be further explored. And of course, this is encouraging results. And the better is countryside and small town connection, because let's say the algorithm is still better to detect the possible highways, let's say crashes, rather than slightly city crashes that are a bit more, let's say, unpredictable. But we are working to move towards and to increase the area under this curve also in cities by enrich the most this is possible the environment. This is the first question that I hope I asked.
Thank you. Coming on to our next question then, what is the process to validate the ground truth about driving behaviour and car crash events gathering?
Yes, we'll move back to the data set selection. That is this. Yes, that is important, let's say, things to underline that maybe I missed in the first time. And crash alarms are just crash alarms. It's not, let's say, we are not allowed to relate them to the actual sinister that the driver made with this policy. With this, just an internal crash alarm system. How it is validated, this one. Unfortunately, I cannot, let's say, share this this information. However, there are two methods to validate the system, and the end, let's say, the logic end of 2.1 gives us a very high percentage of probability that the crash alarm may traduce also to an actual crash. So let's say the ground truth is that we have extremely rare false positives in crash events due to our stakeholder data and our stakeholder technologies.
Thank you, Leonardo. We have a couple more questions if we have time. So
yeah, why not?
One more question. As this is an industrial use case, how is the model made GDPR compliant? And are the driver's insurance rates decided by the algorithm or crash probabilities?
Yes, partially I respond to this question with my last sentence. Let's say we don't check, let's say, the actual sinister crash, the actual denounce of the private driver. We have an algorithm that detects the crash and he label a crash as a sensor measurement and some pattern that's triggering. So basically, the GDPR made is just because they are the drivers knows that we are tracking his behavior because it's in this in his policies, and of course there are anonymized data that we are using, and we collect just aggregate results overall the period. We cannot identify that specific crash in this view. We just have a overall calculation over a month by looking behind 3 months. That's the algorithm.
Thank you. We have one more question, and I think then we will have to close. The question is sent to the panel chat. The sliding window of 3 months to predict the 4th month may not be aware of yearly patterns. Are the temporal differences of risk and mobility demand throughout the year considered somehow? Thank you for the question.
Thank you. Yes, it is, because of course we divide we, let's say, divide the whole data set in test and train, and we just observe the last 3 months. So basically, if we had to predict the crash risk in April, we look in January, February, and March. If we have to predict the crash risk in June, we look at behind 3 months. So basically, each operation is standalone. However, of course, the history of previously happened crashed has been considered, but not for the test, for the last months of test, then observational test. So basically, we have previously history in that here, but we consider just the previously happened. So somehow the last months are pretty much accurate, but we are running also a battery of tests in which we are totally blind of that information. We will find more information at the end of the project, of course.
Thank you, Leonardo. I think that now brings us to the close of our webinar. Thank you everybody for joining us today, and we do hope that you will also join us on Thursday for the last of the webinar in the Big Data demo series. Thank you very much, and goodbye. Thank you.
Thank you all.